2023 May Edexcel paper 1 for the higher tier. All right, so the first question, work out 8.46 divided by 0.15. We need to use long division for this one. So what we can do, instead of looking at these decimals, let's times both numbers by 100. And the reason we do it by 100 is because that's 8.46 and that will multiply by 100, so we get no decimal points. So 846 will be the new number, and we're going to be dividing that by, we also need to multiply this by 100. And when you multiply that by 100, you get 15. So that's what we can look at. Now it's exactly the same what we're doing. This is the same as doing 8.46 divided by 0.15. Often one of the common mistakes that students make is that they think that they have to go back and divide by 100 the final answer. You don't need to do that, because what you did to this one, you did to that one, so you kept the answer consistent. Okay. So how do we do this? Long division. So 15 into 846. What do we do? 15, does it go into the 8? No, it doesn't. So we need to use 84. Now it might help if you have the 15 times table written down on the side. So 15, 30, 45, 60, 75, and 90. That would be enough. So you can see that 15 goes into 84 how many times? 1, 2, 3, 4, 5. It goes in 5 whole times. So we're going to write the 5 right there above the 4 because we used 84. That's why I do it above the 4. And what was the remainder? So if it's 75, that it went in 75 to 84. What's the remainder? That is 9. And we can just write that 9 right there. So now we've got another number to look at, which is 96. How many times does 15 go into 96? So 1, 2, 3, 4, 5, 6 times. So 6. And now there's a remainder. Now for the remainder, we're going to add the decimal here and here. And then what we can do is just add another 0 here, because now it doesn't matter. It's after the decimal point. It doesn't matter how many zeros we add. So now next, 15 into this new number now, 60. How many times does it go into 60? And it goes in exactly 1, 2, 3, 4 times. Exactly 4 times. So the answer, the final answer is 56.4. Let's move on to the next question. Work out 7/3/8 minus 2.5. Give your answer as a mixed number. Now, first of all, we need to convert these into top heavy, both of them. And to do that, we do 7 times 8 and then add the 3. So we do the same thing here. 2 times 2, add the 1. So 7 times 8, let's do that first number right here. So 7 times 8, add the 3. 7 times 8 is 56. Add the 3, 59. So 59 over 8. And this one, that's 2 times 2, 4. Add the 1, 5. So that's 5 over 2. Now, we can't add or take away until we have the same denominators. So if you look at 8 and 2 closely, I mean, we can multiply 8 times 2 and do that to the top as well. But it's probably just easier to take that second fraction, because we can get that denominator to be an 8. And how do you do that? We can multiply the 2 by 4. So if we take this and times that by 4, 2 times by 4 will give us that 8. And we also multiply the 5 by 4 as well. So that becomes 5 times 4 is 20, 20, and 2 times 4 is 8. There we go. And this one, we can just write it as it is. So 59 over 8. And we take that away. Now that we've got the same denominators, we just do the top. Take away the numerator. So 59 take away 20. That gives us 39 over 8. Now remember, the question said that it wants a mixed number. So now you've got to convert that into a mixed number. And how do you do that? You say, how many times does 8 go into 39? 8 goes in 4 times, and the remainder is 7. So it's 7 over 8. And that's your final answer. Be careful in the exam if you get a different question. Sometimes this needs more simplifying. So if you have to simplify that, which you can't do in this case, then make sure you're prepared to be able to simplify that, okay? But right now, this is your final answer. All right, question 3. A cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. Now, I like to visualize things. So this is something I teach my students to do. So I'm going to quickly draw the cube out. And we are told that the surface area of this cube, so surface area is basically all of these faces. There's one there, there's one at the bottom, there's one there. All of those faces added up, that's your surface area. We are told that the surface area is 150 centimeter squared. Now, if you look at one of those faces is a square because it's a cube, right? So we have 6 faces that will divide into that. So we can start off by saying 150 centimeter squared divided by the 6 faces. And this will give us the size of, or the area of, one face. And remember, it's a non-calculator paper, so you're going to have to do this without calculator. So what we can do, I mean, you can do 150 divided by 6, those of you that know how to do it, but let's make things a little bit simple for us. So what we can do here is just simplify that fraction by dividing by 3. So if we divide both numbers, the top and the bottom, by 3, we get 50 over 2, and 50 over 2 is 25 centimeter squared. Right, so what does that mean? This one of these faces is 25 centimeter squared. Now, it's a cube. Remember, it's taken from a cube, so it's a square, and therefore this length here, this length here times by this length here has to give us 25 centimeters. Quickest way to do that is to do the square root of 25, and that is 5 centimeters. So just to go forward, if this is 5 and this is 5, 5 times 5 gives us our 25 centimeters squared. Okay, now so we've got the length of these sides, right? So all of these will be 5 centimeters, 5 centimeters, and 5 centimeters. And we have been asked to calculate the volume. So the volume is all of the lengths multiplied. So it'll be 5 times 5 times 5, and that is 125 centimeter cubed. Don't forget it's a volume. All right, let's go. Next question. Now, this next question, question 4, the table shows information about the daily rainfall in a town for 60 days. And we've been asked to draw a frequency polygon for this information. Now guys, frequency polygon is not, don't get confused with other graphs. I've seen it so many times. You know, bar graphs are drawn when you've been asked to draw a frequency polygon. Histograms are attempted when you try to draw a frequency polygon. And I can see why some people would get confused because of these class intervals, because these are things that they associate with histograms and cumulative frequency graphs and all of that sort of stuff. But remember, histograms is one of the most simplest graphs that you can, I'm sorry, not histograms, frequency polygons are one of the simplest graphs that you can draw. So frequency polygons, you simply just plot these values on here, okay, on the midpoint of these class intervals. So 8, we're going to plot halfway between 0 and 5. Let's go find where that halfway point between 0 and 5 is, right here. So we're going to go up here and find where 8 is. 8 is here. Now I've worked out, if you look at these, it's telling us that from here to here is 10. So that means each of these is worth 1. So that's where 8 is, right here. Let's go mark it. So there's that. That's that first one done. And we'll do that for the rest of them as well. So we've got 24 between 5 and 10. Between 5 and 10 is halfway here. And that's 24. So we go up here. That's 24 right there. Okay, I'm going to go and do the rest of them now. All right, so I've plotted the rest of these. Now, what's next? I just get a ruler and I join my lines up. So let's go and do that. There, 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 and there. Now you can leave it like this, all right? I mean, examiners won't mind too much, but if you notice, this goes down to a 0 here, all right? The first one right there goes down to a 0. So it's better that you go down here like that, okay? So from there to there, go down, and if you look at the last class interval, it goes to 25, and you can do the same thing there. All right, I really advise that you do this because this is a proper frequency polygon. All right, but the other way, I have seen mark schemes allow it. Okay, so if you don't do those two parts, you might get away with that. Okay, but it's better to do it like this. And also to mention, it's a polygon, right? So a polygon needs to be closed shape. Okay, a shape with many sides. Closed. There you go. Many sides. 1, 2, 3, 4, 5. All right, let's go. Keep going. What we've got next? Venn diagrams. All right, so we have a data set. This is just a fancy word of talking about this, by the way. All right, and we need to put those numbers inside our Venn diagram. So this right here, it means all the numbers that go into this. Okay, so they're either here, 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 or outside. Okay. But it's telling us specifically that in circle A must go all the odd numbers. So in this circle must go only odd numbers. B must go all the square numbers. All right. So what we could do first, just to set things up, is let's go to our data set, this, right, and highlight the odd numbers and the square numbers and see which ones are doubles, because what do we know? Inside this area will go the ones that are both odd numbers and square numbers. All right, so let's go and highlight that. So in yellow, I'm going to do my odd numbers. So let's go find all my odd numbers. So 1 is an odd number, 3 is an odd number, 5, 7, 9. Okay, now in another color, let's pick a green. In green, I'm going to find my square numbers. So 1's a square number, 4 is a square number, and I've done the one on the top because it's going to clash otherwise. All right, what else we got? Oh, that's it, that's all this. Oh, actually 9 is a square number. There we go. So those numbers that have got 2 colors on them, right, they will go in the middle right there. Okay, and notice I've not colored in the 6 and the 10 and the 8. That's because they're not square numbers and they're not odd numbers, so they will go on the outside those circles. All right, let's start with the ones that got the 2 colors on top, the green and the yellow. So that is 1 in here and 9. So 1 and 9 will go inside that intersection part. Now in here will go numbers which are only odd numbers and that are not in here already. Okay, so what do we have? We have the 3, the 5, the 7, and not the 9, don't count that. So it's just 3, 5, and 7. There we go. Now in here, same thing. We are going to have all the square numbers, and that is the only ones with green that are not already in here. Okay, and that's just 4 here. And on the outside, we can put our 6, our 8, and our 10. Now let's quickly check that we've got all the numbers in place. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could have just seen that. So we've got 1. Where's 2? 2 is lacking. Ah, I forgot 2. And that it's not colored in, remember? So it can also go on the outside right there. There we go. We've got all the numbers now. And this is very helpful what I just did there, because you need to check that you haven't missed anything out. And you can do that by just counting the numbers. So we've got 10 numbers in here. Do we have 10 numbers here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There you go. Right, let's move on. It says a number is chosen at random from this universal set. It's basically saying numbers chosen from there. Find the probability that number is in set. Now what does this mean? Not B, right? You can see a little dash on top. That means it's essentially saying find the probability that this number is not in B. That's what it's saying. Find the probability that this number is not in B. So if you have a look at your circle, right, here's the B circle right there. You're looking for the numbers that are not in B. All right, so let's quickly write this here. So not in B. So the numbers that are not in B is this, 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 and this. All right, that's the B circle, and these are all the numbers that are outside of B circle. All right, so how many numbers do we have outside? Because it asks for a probability. All right, so it's 1, 2, 3, 4, 5, 6, 7 numbers out of the 10 numbers. So what we say is 7 out of 10. There we go. Question 6, the scatter graph shows information about the ages and weights of some babies. Describe the relationship between the age and the weight of the babies. Right, so relationship, when you see that word buzzword, guys, correlation. All right, correlation, that's what it's talking about. So can you identify what kind of relationship you have here? It's a positive correlation because it's going up, and it's, I mean, the strength of it is reasonably strong, but I wouldn't say very strong, because strength is, if I was to draw a line of best fit here, which I probably would do later, so many of these are close to the line, but they're, a little bit away. So what we can say here is that it's a positive correlation. Now, it specifically says describe the relationship. All right, so you might want to add something here, mentioning the age and the weight of the babies. You could say something like, as the baby, gets older in months, their weight increases. So you could say, as the age increases, the weight of the baby also increases. There you go. Now it says another baby has a weight of 5.8 Using the scatter graph, find an estimate for the age of this baby. So this is what I was saying, we need to draw a line of best fit. So you get your ruler, where's mine? There. Get your ruler and you try to find where the line of best fit might lie. Now, look, this is not a good line of best fit. Between, through, as many points as possible. Okay, so if we have a look at this, we can draw various lines here, but it's just an estimation. That's why it says here, it's an estimation, because your estimation can change depending on what your line is like, okay? So I'm gonna go with something like that, yeah? So let me get a different color and mark that. So there is my line of best fit. I mean, looking back at it now, I think I could have done a little bit better, but it's okay. It goes through, it's positive and the reasonably close distribution. All right. Anyway, right. It says find the scatter graph. Using the scatter graph, find an estimate for the age of this baby. We need to go and find where 5.8 kilograms is on our y-axis. So if we zoom in here, we know that this here is 5. So if that's 5, this is going to 6. Every one of these must be 0.2. So if this is 5, this is 5.2, 5.4, 5.6, 5.8, and then obviously just 6. So what we're looking for 5.8, right? Right here. So we can get a ruler and draw a dotted line, or like this if you want. And you can see, oh, that's a nice place where it hits actually. So we can go down and say, yeah, I'm gonna go with 4. I mean, it's just because of my ruling, all right? But 4 is fine, yeah? So age, let's go for 4 months. Now, depending on your line, your answer may be different to this, but there's usually a range, okay? So something like 2.5 to 4.5, anything in that range is fine. All right, question number 7. The price of a holiday increases by 20%. Damn it, no holiday for me this year then. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. Let's go highlight some stuff here. So we know that it's been increased by 20%. And we are also told that that 20% increase is adding £240 to the price of the holiday. So can we say that 20% is equal to 240? Because that's what 20% increase does. So with that, we want to work out the price of the holiday before the increase. So basically, we're trying to work out what the 100% is of this holiday. Now to do that, remember it's a non-calculator paper. You can do this in a number of methods. You just need to find a way to go from 20 to 100. All right. You may want to go down to, like, let's say 10% and find what that is by dividing this by 2 and dividing this by 2. All right, and that gives us 120, and then you can come up to 100% by timesing that by 10, and you also times this by 10. So that would be 120 times by 10, which is £1,200. Okay, that's one way you could do it. So 100% is £1,200. But if you look at these numbers, another way that you could also do it is, well, we can directly get to 100% from 20% by multiplying by 5. But the challenge with that is a lot of you might struggle with multiplying this by 5 so easily. Right? You might need to resort to long multiplication or something. But what you can do, I just wanted to use this opportunity to teach you that. If you ever multiply by 5, what you could do is multiply by 10 and then divide the answer by 2. So 240 times by 10 is 2,400, and 2,400 divided by 2 is 1,200. Okay, so just something else that you can learn here. Anyway, the answer is £1,200. Right, question number 8. The diagram shows a solid cylinder on a horizontal floor. We've been given the formula for pressure, and we've been given the height of that cylinder. We're told that the cylinder has a volume of 1200 centimeter cubed and a height 40 centimeters. And we are told that the cylinder exerts a force of 90 newtons on the floor. So this cylinder right here is exerting that 90 Newton force on that floor. All right. Work out the pressure. That's what we're trying to do. We're trying to work out the pressure on the floor due to the cylinder. Where do we begin? Right, if we look at this, this is the final thing, because working out the pressure means using that formula. So we need the force, which we have. The force is 90. And we need the area, which we don't have. Now the area of what? We need the area of the surface that is on the floor. okay, the area of that. So we don't need the surface area of this entire cylinder. We just need to know what the area of that part is, the circle, which is on the floor. Okay, that's a rubbish floor, but anyway. Right, so how do we find the area of that circle? Well, we know that to find the area of a circle, we do pi r squared. But we don't have any of that information like the radius, all right? But we are given the volume of the cylinder. So if we use that, let's start with that. So number one, let's start off with the volume of a cylinder. What is the volume of a cylinder? We know it's the area of the cross section, Okay, that's our circle, times by the length, and that's our height, which is 40 centimeters. So we are given the volume. That is 1200 centimeter cubed from the question right there. And the area of the cross section is our circle. All right, we're trying to work out our area of our circle. And our length is 40 centimeters right there or there. Okay, so that's times by 40. Now, how do we find the area? Well, simple. We just do the division. So 1200 divided by 40. Again, non-calculator, cancel those. 120 divided by 4, that is 120 divided by 2, which is 60. Divide that by 2 again, that is 30. So the area is 30 centimeter squared. That's our area of our circle. Now, we've got our area. We can now find the pressure. So the pressure formula is force, which is 90 newtons, divided by the area, which is 30 centimeter squared. Again, no calculator, let's cancel those, the zeros. 9 divided by 3 is 3, so it's 3. Now the units, it's usually given here, or it is given here, but if you didn't know, it's Newton over centimeter. So you could write Newton centimeter like that. Okay, question number 9. Use these graphs to solve the simultaneous equations. Find the value of x and y. This is only for 1 mark. Okay, look at that. Okay, it's 1 mark, so it must be really straightforward. And if you want to graphically solve simultaneous equations, there's one line, there's one line. What we're looking for? We're looking for where they intersect, and where they intersect is right here. So it's simply just reading the x and the y coordinates right there. So this is our x coordinate. What is that? If that is, let's work this out first. So that's 5. That means 1, 2, 3, 4, 5. So that's 6. Okay, so x is equal to 6. And if we go across here, that's our y coordinate. And again, this is minus 5. So each one of these is minus 1. So that is minus 2. So y is equal to minus 2. So our final answer, x is equal to 6 and y is equal to minus 2. Let's go, keep moving. Number 10. Now, if you've answered all these questions so far, you've probably got enough to get yourself a grade 4, obviously correctly, okay, on this particular paper. Let's have a look at number 10. Here is a pentagon. The angle AED is equal to 4 times what ABC is equal to. Let's go and look for where AED is. So that's AED. It's talking about this angle right here. Let's go mark it. So that is AED. And let's go find where ABC is now. So ABC, right there, the angle right there. Now, we are told that this is worth 4 times what that is, okay? Now, how can we represent that? Okay, I know a lot of you might be thinking about pentagon. Let's find the some of the interior angles. We'll do that later, but we're just setting this up right now, okay? So if I call this, let's say, an x, what will I have to call this if this is 4 times bigger? Yeah, 4x. Okay, so I can call this 4x. Now look at this. Yeah, 1, 2, 3, 4, 5. I've got something that I can add together and make it equal to the sum of the interior angles of a pentagon. And how do we find the sum of the interior angles of a pentagon? We do n minus 2 times by 180. N is our number of sides. Here the pentagon has 5 sides, so it's 5 minus 2 times 180. That's 3 times 180. 3 times 180 is 540. No, I didn't calculate this in my head. I'm so used to finding the answer here that I knew it, but yeah, it's not that difficult anyway. So you could just do 3 times, I don't know, 18 and then add the 0, something like that. And if that fails, guys, just go for it. Never be afraid to do 3 times 180 long multiplication. All right, don't waste time, get to it. Okay, right, so we've got 540 here. So now the second step, so that's first step. Second step is to basically add all of those together. So 120 plus 4x, yeah, we'll keep it like that for now, plus 135 plus 110 plus the x. So I've added all of these, yeah, all of these. Now that is going to equal to 540. Now if I go and collect my like terms, I've got the 4x and the x together, that will give me 5x. And then I just add all these numbers together. Okay, and again, you could do it in your head, or you could actually use a column method if you struggle with this. So whatever way you fancy, guys, do it. But 120, 135, 110, that gives us 365. So that's equal to 540. Next, we need to take the 365 to the other side, all right, by taking away from 540 and 540. Let's write it down so you understand what's going on. There you go. So 5x is equal to 540, take away 365. So 5x is equal to 175. And to find what x is, we're going to do 175 divided by 5. So now we've got this problem here. So you can go to long division. All right, so how many times does 5 go into 1? It doesn't. How many times does 5 go into 17? 5, 10, 15 goes in 3 times. The remainder is 2. How many times does 5 go into 25? It goes in 5 times. So the answer to this is x is equal to 35 degrees. Now, that's not the answer, the final answer, because it says work out the size of angle AED, i.e. what is this 4x value? Well, if you know what x is, it's 35. So AED, angle AED, would be 4 times by 35. And you could do 35 times 2, which is 70, and times that by 2, which is 140. So that's the same as getting 4 times 35 directly. So angle AED is 140 degrees. Next question, 11. We have this index number on the top and on the bottom, and we have to write this in the form ax to the power of b, y to the power of c, where a, b, and c are integers. All right, now let's focus on the top right here. What happens when you have a bracket that is being powered with stuff inside the bracket that has indexes? Okay, we should know the rule for this, right? Well, we should know, but I'm sure some of you might be struggling right now. So I'm going to quickly remind you, all right? If you have something, let's say, x to the power of a, and you have a number outside, you multiply those numbers, yeah, a and b, all right? You multiply it, so it becomes ab, like that, all right? So if we look at that, so we've got 6x to the power of 5, y to the power of 3 squared, all right? The 2, all right, it's powering everything inside. So it powers the 6, it powers the x to the 5, and it also powers the y to the 3. So let's write this out. We get 6 squared, x to the power of 5. Now remember, you multiply the 5 and the 2, so that becomes a 10. And y, you do the same. So 3 and the 2, that becomes 6. So 6 squared is 36, x to the 10, y to the 6. That is the top. Okay, that's the top. Now if we do the same thing to the bottom, all right, let's highlight that. So on the bottom, let's write it here. So 3x squared, y to the 7 times 4x, y to the minus 3. All right, what happens here? Well, the 3 and the 4, we can just multiply them. That gives us 12. And then we've got x squared and x to the power of 1. There is a 1 there. It's not written. We don't need to write a 1 in algebra, but there's a 1 there. So what do you do when you're multiplying? Well, you just add the powers. So 2 and the 1. That will give us x to the power of 3. And same goes for the y. So that's y to the 7 plus minus 3. Now, when you do a plus minus 3, the minus is dominant. So it's 7 minus 3. 7 minus 3 is 4. So it's y to the power of 4. And that's the bottom. Now, if we put them on top of each other now, so this one was on the top. So that's 36x to the 10, y to the 6. And that one was on the bottom. So 12x cubed, y to the power of 4. Now we're ready to do the next part. So the next part is division here. All right, so 36 divided by 12. How many 12s go into 36? That's 3, a big 3, so that's gone. Now we've got x to the power of 10 and divided by x to the power of 3. When you divide, you take away the power. So you do 10 take away 3, which is x to the power of 7. And then you do the same thing for your y's. You do 6 take away 4. So that's y to the power of 2. And that's your final answer. All right, question number 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. Find the probability that Martha will lose at least one game. Usually with these questions, you have to fill in some of these probabilities, but it's been done for you. That's great. You just need to answer the question. So losing at least one game. Now, there's two ways to do this. There's the quick way or the long way. All right, the long way is basically to find out all the combinations where they lose, Martha loses at least one game. So like, for example, winning this one would mean losing that one. Okay, that's one combination right there, which is to multiply those fractions. Another one would be to lose this one and win this one. That's winning at least one game. All right, that's that. And we've got losing both games. That's losing at least one game, isn't it? Yeah, because they lose both of them, to add that. Right. But the quicker way is, if you know those probabilities that you've seen me highlight, did you notice that I didn't do anything with the one on the top, which is the win-win? Okay, that's not losing anything, isn't it? So what we can do is, all probabilities we know is out of 1. So we can use 1 minus the probability of her winning both games. So we've eliminated the possibility of her winning both games, which means that somewhere in our probability will be a losing game. Okay, so let's find the probability of her winning, which is 5 over 8 times by 2 over 9. Okay, so non-calculator, remember, so we're going to do this for our calculator. That's 10 over 72. So how do we deal with this without a calculator? Well, let's make 1 72 over 72 and 10 over 72. Okay, remember, we can make 1 into any fraction that we want, because 72 over 72 is still 1, and I use 72 because this has a denominator of 72. Now I've got two fractions which I can just take away. So 72 take away 10 now is 62 out of 72. And that's my final answer. You don't need to simplify the final answer, by the way. Some students like to do that, but it's not a requirement. Okay. All right. Question number 13. Y is directly proportional to x. Y is equal to 24 when x is equal to 1.5. Work out the value of y when x is equal to 5. Right. So where do we start? We can start off by making this y, and using that sign for proportion, is proportional to x. We can start off right there. And then this sign can be replaced with y is equal to k. Okay, and then we can add our x. Now, using the information they give us, all right, we have to find the value of k. So we sub in y equals 24 here and x equals 1.5 there. All right, so using the information, don't try to go gung-ho, yeah, and work this out straight away. You won't get very far. So this is 24, k we don't know yet, times by 1.5. So to find what k is, we're going to need to do 24 divided by 1.5. Okay, so how do we do with this? Well, let's multiply top and bottom by 10. That gives us 240 divided by 15. And we can use long division for that. So 240 divided by 15. How many times is 15 going to 24? Goes in once, left over is 9. How many times does 15 go into 90? We did that earlier, didn't we? So you can go back up there and look at it, but we know it goes in 6 times. There we go. So that k value is 16. All right, now what do we do with our k value? Well, remember, we wrote this. Well, now we can replace the k. So y is equal to 16x. That becomes the formula that we are now going to use to work out the value of y when x is equal to 5. So y is equal to 16 times by our x, which is 5. So we need to do 16 times 5. Remember, times by 5 what you can do is times by 10, divide the answer by 2. So what's 16 times by 10? 160. Divide 160 by 2. That is 80. So y is equal to 80. There you go. That's your final answer. All right, question number 14. Write 1 over 16 in the form 4 to the power of n, where n is an integer. So what is, we need to introduce 4, okay? We need to somehow find a way to introduce 4. What's the link between 16 and 4? Okay, we know the link between 16 and 4 is that 16 could be written as 4 squared, like that. Okay, so I've replaced 16 with 4 squared. And now, our knowledge of negative indices. So how do we treat this? Well, the 4 can be written like that, and that 2 has a negative like this, and now we've written it. Now can you see n is in the position of -2, so therefore n is -2, which is an integer. Okay, it's just a negative integer, but an integer nonetheless. So part B of this question, work out the value of 8 to the power of 5 over 3 minus 9 to the power of 3 over 2. How do we deal with this? Right, if we rewrite each of these, so what happens when you have a power, which is a fraction? That 3 means the cube root of 8, and the 5 means to power that, okay, like that. So that would be, for the 9, it would be the square root of 9. We don't need to write the 2 there, but you can do if you want to, so that it's consistent with the other one, and it will be powered to 3, okay, like that. Now, what is the cube root of 8? The cube root of 8 is 2, so that's 2, and then the 5 is hanging around outside like that. What's the square root of 9? That is 3, and the 3 is hanging around to power it. So what is 2 to the power of 5? 2 to the power of 5 is 32. 3 to the power of 3 is 27. So what is 32? Take away 27. It is 5. So the value of that is 5. Question 15. The equation of line L1 is y is equal to 2x minus 5. The equation of line L2 is 6y plus kx minus 12 equals 0. L1 is perpendicular to L2. Find the value of k. You must show all your working. Now the questions are going to start to get harder now. But by this point, if you've done everything correctly, if you understood it, I would say you're well on your way to between a 6 and a 7, perhaps. Yeah, I haven't counted the marks, but... All right, so what might help here, right, is a diagram. So let's quickly do a sketch, all right? You don't have to do this, but it does help many of my students when I teach them. So if we draw L1, that has a y-intercept of -5, so somewhere down here. So it would be a positive gradient, 2x, and that. So that's line L1, which is y is equal to 2x minus 5. Now, if L2 is another equation and it's perpendicular to L1, that means it must come down anywhere, somewhere like that, right? So we can actually rearrange this into the form y equals mx plus c first, actually, to do a better representation of the drawing. Yeah, so if we make 6y on its own first, take everything over to the other side, that would give us a minus kx plus 12, and then we divide by the 6. That would be, okay, it doesn't help that much, k over 6 x plus 12 over 6 is 2. Okay, at least we know that it goes through 2 though, yeah? That's quite useful. And we also know that it's a negative gradient, which we knew that anyway, it would be something like that. So yeah, it does help still. All right, it's not all gone to loss doing that. So yeah, I'm not going to try to pretend that it goes through that point right there. That's why I went a little bit off it, yeah? In fact, I might need to draw it a little bit better than that, really. It's not to scale, that's why. All right, but just know, like, look, this is their meeting point, all right, somewhere here, and it's not on the x-axis, all right? That's what I'm trying to make sure that you understand. Anyhow, work out the value of k. Right, what do we know about gradients of two lines which are perpendicular, right? This is L2, yeah? We know that m1, the gradient of one of them, times m2, the gradient of the other one that's perpendicular to it, has to equal -1. We know that, right? So why don't we go and find the gradient of each line? So if we look at this, the gradient of that, let's call it m1, is 2, all right? And the gradient of L2, the right, it's up here, so y equals minus k over 6x plus 2. The gradient of m2 is, well, it's got k involved, but we can just write it as k minus k over 6. So that is m2. So m1 is 2 times by m2, which is minus k over 6, and that has to equal minus 1. Look what we have now. We have an equation that we can solve to find what k is, and that's what the question is asking us to do, remember? So how do we do that? Well, 2 times this fraction, what we can do, cancel by 2, divide by 2. So 2's gone, that becomes a 3. So we end up with minus k over 3 equals minus 1. Take the 3 to the other side by multiplying, so that becomes k is equal to minus 3. We don't want minus k, we want k. So we're going to switch sides, so k is equal to 3. There you go. Done. Question number 16. Here is a sphere. The surface area of the sphere is given, and we are told that 3/8 of the surface area of this sphere is 75 pi centimeter squared. Let's go and highlight some of that stuff. So the surface area of this sphere is that. Find the diameter of the sphere. So here's the radius. The diameter is obviously 2 times the radius, so all of that. That's what we're looking for. Give your answer in the form a root b, where a is an integer and b is a prime number. So we're dealing with surds at some points. All right, where do we begin? Well, let's look at that statement right there and see if we can use that somehow to link them. So if we are told that 3/8 of the surface area is 75 pi centimeters squared, what we can write is 3/8 times by, remember, it's the 3/8 of the surface area of this sphere. Okay, now everything's in general, we're using r's, so we can say 3/8 of 4 pi r squared is equal to what? What's it equal to? It said 3/8 of the surface area is equal to 75 pi. All right, so we can write 75 pi centimeter squared. So now, if we find the value of r, we can multiply that by 2 to find the diameter of the sphere. All right, let's go. So let's do this first. Look at that. Yeah, what can we do here? Well, the 3 will multiply with the 4, or you can cancel the 4 and the 8 like that. Let's do that actually. So divide that by 4 is 1, divide that by 4 is 2. So we end up with 3/2 times pi r squared is equal to 75 pi. Next, we can cancel the pi's on both sides. So goodbye pi. So we have 3/2 r squared is equal to 75. Now we can multiply by the 2 here onto that side. So that becomes 3r squared is equal to 75 times by 2 is 150. Then we can divide by 3 now. So we get 150 divided by 3 r squared. And r squared, what's 150 divided by 3? That's 50. All right, so now we want r, square root of 50. All right, now remember, it was saying that it wants it in that surd form. That's what it is. You need to break down the square root of 50 by the largest square number that goes into that is 25 times by 2. 25 is 5, so 5√2 is our final answer. And 2 is a prime number. Remember, it was saying b is a prime number right there. Okay, and a is an integer, which is 5. So that's our final answer. No, it's not. No, it's not. I lied. That was just a radius, wasn't it? I forgot. So what we now need to do is times this by 2. So the diameter is 2 times 5√2, and that is 10√2. See, look, these are the kind of mistakes that you can also make in the classroom. Not in the classroom, the exam. All right, these are the kind of mistakes that students easily make, and they lose those, you know, valuable marks. All right, so look, I just did it right now. It's very, very easy to happen to anyone. Imagine the pressure of an exam. This is what it does. So be very careful. Use your time wisely. Anyway, let's move on. Question 17. So we want to make x the subject of this formula. First step, guys, get all of this onto that side. So we got y bracket 5x plus 3, 4, 2x minus 7. Expand the bracket, so you get 5xy plus 3y. Expand that bracket, you get 8x minus 28. Now we're going to take x's onto one side. Okay, so I'm going to move this over here. Okay, so 5xy minus 8x, and also I'm going to move you over there. Okay, so you're both negative now. Minus 28 minus 3y. Now here I'm going to factorize the x out. Okay, because I want x on its own. So 5y minus 8 is equal to minus 28 minus 3y. Now I've got x on its own by doing the division. So minus 28 minus 3y divided by 5y minus 8. Boom, done. Now you might get different variations of this final answer depending on what you did, why you did it, etc. So here are other variations that are valid for this, okay? So you could get x is equal to 28 plus 3y over minus 5y plus 8, or you could get a variation of x is equal to 3y plus 28 over 8 minus 5y. And how it was done, it was, yeah, don't worry about it, but it's basically multiplying all of these by minus 1, top and bottom. All right, but you don't need to worry, okay? Any of these are valid, okay? Any of these are valid. All right, question 18. I remember when the students came out the exam, they were discussing this a lot. 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480p. The cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes is in the ratio 5 to 9. Work out the cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes. Now, how do we set this up? Well, let's look at that first sentence right there. What we can say is 7c for carrots plus 5, let's use t for tomatoes, is equal to 480p. Okay, it's in pennies. I'm not going to add the p here in case you think it's a variable. Now, that's that. Now, this next sentence, what can I do with this? Okay, the ratio one. I am told that 1 kilogram of carrot to the ratio of 1 kilogram of tomatoes is in the ratio 5 to 9. Okay, I could write it like that. Okay, so carrots, 1 kilogram of it represents the 5, and tomatoes, 1 kilogram of it represents the 9 here. Okay, so I've got that. So what's my next move? This is where you have to find a way. You're solving this simultaneously. You have to find a way to use this and this to find, a merge somewhere. Yeah, you have a relationship. How do you use this and this now to solve this simultaneously? All right. What we could do is if we take this, I mean, there is more than one way of doing this. Okay, so I just want you guys to be fully aware of that. Okay, you might have seen it differently. So what we can do here is we know that t divided by the c is equal to the 9 divided by the 5. Let's write that down. T divided by c is equal to 9 divided by 5. All right. Now, if I make c or t the subject, it doesn't matter which one. Okay, I'm going to make c the subject. All right. I'm going to multiply the c on the other side. So I get t is equal to 9c over 5. And then I'm going to times by 5 over here and then divide by 9. So I get, what do I get? 5t over 9 is equal to c. Okay, so that's my c. What I'm going to do with my c here, okay, is I'm going to substitute it into that c. All right, so let's do that up here. So this is our sub step. So this is step number, let's call this step number 1. Let's call this step number 2, and now we're doing step number 3 to sub it in. So we've got 7 bracket, and our c is 5t over 9 plus 5t itself from here, remember, yeah, that's equal to what? 480p. Okay, I won't forget that. So 7 times 5, that is 35 over 9. So 35 over 9t plus 5t equals 480. Now if I solve that, what will happen? I'll find what t is, isn't it? So how do I solve that? Let's multiply everything by 9. So 9 times 9 times 9. Okay, that will make this 35t. 5 times 9 is 45t. And oh gosh, 48 times 9 now, or 480 times by 9 we need to do. So we're going to have to struggle here a little bit by doing, let's do 48 times by 9. We know that the 0 can just be added, by the way. So 8 times 9, that is 72. 9 times 4 is 36. Add the 7, 43. So 43. So 432 is 48 times 9. But we want times by 480. So we're going to add the 0 there. So it's going to be 4320. Next, let's add the 35t plus the 45t. That is, what's that? Add the 5, that's 50, 80t. and then 80t is equal to 4320. We can cancel the zeros now, look. Yeah, 8t is equal to 432, and then t would be equal to 432 divided by 8. Now, how do we do that? We can divide by 2, divide by 2, divide by 2, 3 times. Okay, that's one tactic. Or you can just simply keep simplifying it down, yeah? So, yeah, which is basically dividing by 2. So what is that? 432 divided by... I'm only doing this because it's a non-calculator, right? You're going to have to find ways to do things like this mentally. What's that? That's 4 divided by 2. 432, that's 200. 32 divided by 2 is 16, 216. Divided by 2 again, that's 2, 216, 100. Divide the 200 and then 8, so 108. And divide by 2 again, that's nice, that's 54. Okay, so tomatoes is 54. Remember, it's in pennies, so 54p. Now, I just need to go and find the carrots. Now, I've got this formula. I can just use that to find the carrots if I want. So I can just sub it in there. Do we have any room? No, we don't. Let's make some room. 1 second, guys. Let me make some room here. I'm going to make this all small. There. All right, so now carrots will be 5 times t, and t is 54, divided by 9. Okay. Okay, so 5 times 54, we can do 54 times by 10, which is 540, and then divide that by 2. And what's that? 540 divided by 2 is 250, divided 40 by 2 is 20, 270 over 9. And then here, hide that, 0, and then 27 divided by 9 is 3. So put the 0 back, that's 30. So it's 30p. So the carrots is 30p and the tomatoes are 54p. All right, next question, number 19. The menu in a restaurant has starters, main courses, and desserts. There are 5 starters, 12 mains, and X dessert. There are 420 different ways to choose 1 starter, 1 main course, and 1 dessert. Right, these questions are actually very straightforward. So you got your starter, which is 5 of those, times by your 12 main courses, times by your desserts, and that should equal 420 different ways. And you want to find the value of X. That's what you're doing. So 5 times 12, that is 60. So you got 60x is equal to 420, and then x would be equal to 420 divided by 60. Cancel the zeros. 42 divided by 6. 42 divided by 6 is 7. So x is equal to 7. So there are 7 desserts. So question 20, for x is greater than or equal to 0, the functions f and g are such that, and you've been given the equations for both of them. Right, what is this first one? A, inverse of g. So how do you find the inverse? Right, what I do is I write y equals root x plus 2, which is over 5, which is the equation of that function g. And then I make x the subject. All right, so that's the aim, to make x the subject. So times the other side by 5. So you get 5y is equal to root x plus 2. Take the 2 to the other side. So 5y minus 2 is equal to root x. I don't want root x. I want x. What do? I square both sides. So x is equal to the square of 5y minus 2. So 5y minus 2 squared. So that is x on its own. So my final answer, what I'll do is just replace the y that I have when I write it. So it will be 5x minus 2 squared, and that is the inverse. Part B, solve gfx equals 3. So we need to find the composite function, so we'll get the f and sub it into g first, and then make it equal to 3. So we'll get f, all right, and sub it into g, wherever we see an x, which is right here. That, in here, where I've highlighted the x, would go all of 3x plus 4. All right, so let's do that first. So it will be gf, this is what gf would be, the root of 3x plus 4. That's where I've put my x. Remember that, yeah? That's where I put the x, which is all of that, f, okay? And you might be wondering, saying, why didn't you do the other way around? It's always the letter that's closest to the bracket that you take and put into the other one, all right? So that's why you take the f and put it into g, because f is closer to that bracket. So next, I add the 2 here. So plus the 2 and all over 5. Now, this is equal to 3. Because remember in the question it said it's equal to 3. So root of 3x plus 4, that's a dodgy root there. Let's fix that. plus, okay, I need to move down a little bit, running out of space there. All right, plus 2 all over 5. There we go. We need to solve that now. So how do we solve that? Let's times both sides by 5. So that would be 15 is equal to root 3x plus 4 plus the 2. Take the 2 to the other side. That gives us 13 is equal to root 3x plus 4. Square both sides. So 13 squared is 169. And that makes that come out the square root. Take the 4 to the other side. So 165 is equal to 3x. And then divide by 3. So x is equal to 165 divided by 3. And 165 divided by 3. If you do 150 divided by 3. That's 50, and then the 15 that's left, 55. So that's 55, not degrees, what am I doing? Just 55, whatever that was. X is equal to 55. Yeah, that's the answer. X is equal to 55. All right, question number 21. A, B, and D are points on a circle with a center O. C, D, E is a tangent, so this is the tangent here. Work out the size of the angle A, D, C. So we're working out this. Okay, let's go mark it. All right, that's what we're working out, yeah? ADC. All right, so what do we know about our circle? What kind of theorems can we use here? All right, we've got this radius, and this is a tangent, and we know that radius and a tangent meet at right angles. So that is a right angle right there. Okay, what else can I use here? Okay, so here, look at that. We've got this angle here, 64. From that same arc, we've got that right there. So we can work this out if we want to. This would be, you know, that one, usually it's written like that. Angle at the center is twice the angle at the circumference, right? That's the rule that we'd normally use for that, isn't it? So that would be like 64. But what's another rule that we know? We also know that if you have angles in the same segment like this one, then any other two lines that run off those same two points or the arc, these are the same, right? So that's the same. So that's 64. Sorry, that's not 64 though, is it? That's half of 64. That's 32. Yeah, 32. This would also be 32. Okay, because it applies to this rule. Angles in the same segment. All right. So we can mark this now as 32. So once again, just in case some of you got confused with that earlier one. So you know this angle here, yeah? That is going to be half of 64. Half of 64 is 32, right? Boom. We agree with that. Now we know another rule, which is that if you have angles in the same segment here, for example, I'll do it over here, this would also be whatever that one is. Okay, and we know that one is 32. So that would also be 32. Well, this down here happens to be one of those angles. Okay, so that's why this is 32. All right, so we've got that. Now, where are we? Okay, we've got a little triangle thing going there. So what we can do is find this angle. Here would be the same as that angle because they're vertically opposite. So let's go and find this angle first. So this one right here, that's going to be 180 take away from 32 plus the 51. So that right there is 97. So that is 97. So are you 97. Remember, vertically opposite. Yeah. Does it ask for reasons? Write down any circle theorems that you use. All right. So we need to write down some reasons. Okay. So this one here is angles in the same segment, and also this one here is what was it? Angle tangent meets radius at 90. Okay, you need to write down the reason because you know, marks are given for these things. All right, so that's that. Also, we did use angle at the center. Angle at center is twice the angle at the circumference. Okay, yeah, that's just simply this and that. Yeah, that's also why this is 32. Actually, you don't really need to use that one, if I'm honest, because if you visualize it like that, then this is the angle at the circumference, this is the angle at the center. You could have done it like that, yeah, but I'll keep it there for notes. Okay, so now we can find this angle here because this is another triangle. All right, so you might start this differently to me, I mean, circle theorem questions, there's more than one way of doing it, yeah? So totally fine. So what is that? Let's go and work on that. So that's going to be 180 minus 64 plus 97. All right, so once again, 64 plus 97, that's one, that is 11. 6 and 9 is 15, and the 1 is 1661. So 180 minus 161, that is 19 degrees. So right here, I don't know if you can see that, that is, let's just write here 19 degrees. Okay, right, what we got here, look, this whole thing is 90. We know that this is 19 degrees, and we try and work out our purple one. Can you see what's going on? That's going to be what now? So ADC, angle ADC, is going to be 90, take away the 19 degrees. And that is 71. Okay, there you go. All right, so question number 22. We have a cuboid. And we've been given the lengths. A to F is 6.8 centimeters. So let's write that down. And F to C is 13.6. So F to C, you can see, goes through our cuboid right there. So that's 13.6 centimeters. We have been asked to calculate or work out the size of the angle between FC and the plane ABCD. Now let's start with the plane. The plane is ABCD, which is on the floor. That is the plane right there. And we want to work out the angle between FC, which is there, and the plane. So what we can do here is draw a right angle triangle by doing this, like that. And that is the angle that we are looking for. Let's call that X. Now if we draw this triangle in 2D, so we can have a proper look at it like this. Okay, so there's our right angle right there, which is here. That is FA, and we know that's 6.8 centimeters. And the angle that we're looking for is right there, and that's our C. So we know that this is 13.6 centimeters. So how can we find this angle? Well, we can use trigonometry because it's a right angle triangle. We can call this the opposite side, and this is the hypotenuse. And what uses that? It's from SOHCAHTOA, we use sine. So we'll have sine, our x, which is our angle, is equal to the opposite, which is 6.8, divided by the hypotenuse, which is 13.6. Now we're calculating an angle, so we do the inverse operation. So inverse of sine, 6.8 over 13.6. If you put that into your calculator, oops, no calculator. Ouch, how do we do that? Well, let's look at that fraction, 6.8 and 13.6. If we first of all multiply everything by 10, we can have 68 divided by 136. And then we cancel down. So we can divide both the top and the bottom by 2. So 68 divided by 2 is 34. 136 divided by 2 is 68. And then divide by 2 again, and we can keep doing that until we simplify it fully. So 34 divided by 2, that gives us 17. 68 divided by 2 is 34. And 34, oh, hang on, we can divide both of them by 17. So 17 divided by 17 is 1, and 34 divided by 17 is 2. So we have a half. So really what we have here is inverse sine of a half. In other words, let's actually go back here, okay, because it would have been easier to do it from there actually. So instead of 6.8 over 13.6, if we replace that with our half, we can have sine x is equal to a half. And we can calculate that because we know that 30 degrees, basically sine 30 is equal to a half. So therefore, x would be equal to 30 degrees. And there we go. And you can do that using your fingers, or you can use a triangle, okay, to find a sine of 30. All right, question number 23. We have to make that surd fraction, take away the other surd fraction into that form. Right, where do we begin? Right, let's start off. Look, can you see the denominators are different? Let's make the denominators the same. And to make them the same, we can multiply this fraction with root 3, and we can multiply this entire fraction with 4 minus root 3. So let's go ahead and do that. So it's 3 root 3 times by root 3, that's that one, and then minus 2 bracket 4 minus root 3. And on the bottom, we can just multiply them like this. Okay, so if we expand everything, so 3 root 3 times 3, that's 3 times 3, because these, they multiply to give you root 9, which is just 3, and that's that, and then the 3 tags along and multiplies. And on the second part, that's minus 2 times 4 is minus 8, and then root 3, which is a negative here, so be careful of this. This will give us an overall positive, that will be plus 2 root 3. On the bottom, we have 4 root 3 minus 3, and then if we now calculate the tops, that's 9 minus 8 plus 2 root 3 on the bottom. Can stay as it is for now. 9 minus 8, that gives us 1, so we get 1 plus 2 root 3 over 4 root 3 minus 3. Now, it still doesn't look like this, can you see? Because on the bottom, we need just one value, one integer for c. And we've got this, which means we need to rationalize. Okay, so we're going to rationalize this now. Okay, and what is that? To multiply the top and the bottom by the bottom, but changing the signs. So it's going to be 4 root 3 plus 3 all over 4 root 3 minus 3 in a bracket, and then 4 root 3 plus 3 again. So if we expand the top now, so we have 1 times that, 1 times that, and then we'll do 2 root 3 times that, and 2 root 3 times that, and we'll do the same thing for the bottom. So we get 1 times 4 root 3, which is just 4 root 3. 1 times 3 is plus 3, and then 2 times 4 is 8. Root 3 times root 3 is 3. That's that. And then the last part is just 3 times 2, which is 6 root 3. There we go. On the bottom, we get 4 root 3 times 4 root 3, which is 16. Root 3 times root 3 is just 3. And then you know that when you do this times that, they cancel because of these signs. Okay, so I'm just going to just do the last part and leave that out. Okay, so I'm just going to multiply those two, which is minus 9. All right, let's go and simplify this a bit further. What we got here, we can take those two terms and collect them. So that's 10 root 3, and then the 3 plus the 8 times, which is 24. That's 24 plus 3 right there. 24 plus 3 is 27, so that's plus 27. On the bottom, we've got 16 times 3, which is 48, and 48 take away 9 is 39. Now what we got, let's see, we can compare it up here. So A is 10, B is 27, and C is 39. Okay, there you go. So A equals 10, B equals 27, and C is equal to 39. And that's your answer. Right, final question. Hope you're still here. If you are, don't forget to give this video a like, and please do share with your friends so that they can benefit too. Find the set of possible values of x for which we have a quadratic and another quadratic. You must show what you're working. All right, so we need to look at these individually. Let's look at that one first, factorize that. So it's a difference of 2 squares, you can see that. So it's going to be 2x, 2x, and plus 5 and minus 5. Okay, and this is less than 0. Leave that for now. You can treat this as equal to 0 just for like doing what you need to do next. You'll basically find the limits here. So it's going to be minus x is equal to minus 5 over 2, and on this one it's going to be x is equal to positive 5 over 2. If you sketch the graph of this, you've got minus 5 over 2 on this side and positive 5 over 2 on this side. It's going to be a happy graph, so it's going to be a smiley quadratic like that. We are looking for what? We are looking for less than 0, where y is less than 0. So y is less than 0 right here. Okay, right there. So it's going to be the range. X is less than, and greater than on that side, 5 over 2 there, and minus 5 over 2. Okay, we'll come back to that. Let's work on this. Now, on this one, we have a negative x squared. You can make it positive if you want to. It's totally up to you. Or you can just deal with it in a negative sense. But let's actually make it positive just to make life easier. So we're going to leave the greater than sign as it is, right? I'm going to take 0 over to this side, which is still 0, and all of that over to that side to change some of those signs. So it's going to be 0 on here, and it's going to be positive 3x squared. Let's start with that, plus 5x minus 12. And now if we factorize that, you can factorize this whichever method you want, AC method or whatever. But I'm going to do it here real quick. So it's going to be 3x, x here. We want something that multiplies to give 12 and adds to give 5, 3 times 3, yep, 3 and 4. So it's going to be plus and minus. So therefore, once again, x is going to be treated with an equal sign here, by the way. So, but it's not, you know that. Or x is equal to minus 3. So these are limits. So it's just for the sketch. So we have minus 3, and let's just put 4 over 3 here. Right, now we're using this version of it, okay, not that version. So it's still a happy graph, okay, because in this version that we chose, x squared is happy, okay, so positive. So it's going to be like that. Now what do we want? We want where y is less than 0 this time, yeah, because this part here is representing y, and y is less than 0. Okay, so once again we want this part of our graph. So we want x is less than 4 over 3 and greater than minus 3. Now we need to put both of these on a number line. So if I just sketch a quick number line and just add some values, and the values got to be incorporative of these, obviously. Let's do minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and 5. Right, let's sketch this one first. So that's 2.5 and minus 2.5. Let's do, where's that, minus 2.5 is there, positive 2.5 is there. Join them up. Do I color them in? No, I don't, because they're not equal to. Yeah, they're not equal to, so they won't be colored in. And for the other one, it's minus 3 here and 4 over 3. And 4 over 3, that's 1 and 1 remaining. So 1.33 recurring. So we can just estimate it somewhere, 1.3 recurring somewhere here. Okay, there. And again, it's not colored in. All right. Now, what are we looking for? We're looking for the paths where they both are the same. Okay, so it's here up to this point. They are the same. So we can use this one's value, which was minus 2.5, minus 5 over 2, which is minus 2.5, and put x here. And for this one, that was from the 4 over 3. So it's 4 over 3. And that is our final answer. So we can put it here. X is less than 4 over 3 and greater than minus 5 over 2. Hope you enjoyed this video, and if you liked it, don't forget to give it a thumbs up. Please share the channel with others, and don't forget to see paper 2 when it's out, and paper 3. Goodbye for now.